to Z-Tech Almanac. This is part 2 of the Yeesu FRG-7 restoration video. Here we'll actually do the work to recap the receiver and see if it works, or if it doesn't, we'll see if there's other problems. We'll look at the tuning and we'll of course test it out and see how it receives on the AM bands and on the shortwave bands as well. Well, let's get to it. So, to test the ripple, I looked at the schematic a little more carefully, and there is a filter choke right here. And so what happens is that the AC comes out of this transformer, goes through a couple of filter capacitors, goes through this choke, and then the output of this choke goes to the audio amplifier and also to the transistor power supply circuit. And so the amplifier is actually, is being fed off of this choke here. So to see, the ripple current, we'll just need to test, both ends of this choke. Obviously one is the input, the other one is the output, and I'm just going to try both of them because I don't know which one's what. But the lesser the ripple current that's less, that's going to be the output, and that's the one that's going to the audio amplifier. So we'll see how much ripple do we have there, and I'll zoom in on the scope here for just a second when I measure one side or the other, and we'll find out if there's an actual problem. Okay, so we have the radio on and the scope. Lots of noise being made, and I have the scope probe hooked up to the choke, at least one side of it, and we see that there is a little ripple, and the scope says that the amplitude is 64 millivolts or so, and RMS is about 35 millivolts. And so we'll see, let's look at the other side and see if that's the same or not. Well, yes, the other side is quite a bit higher. That's 640 millivolts amplitude and 210 millivolts RMS. So this has to be the input, and then this has to be the output. So the choke is working, but the ripple is there. So we got about, the amplitude is up there and quite high in the 68, 70, it's jumping around millivolts. So that would explain some of the noise that we're hearing, some of this filtering into the audio amplifier. So we'll see if I change some of those filter capacitors, if this is going to go down, and subsequently the audio should improve as well. I just want to mention one more thing regarding safety. So this is, I just left my hook up the way it was. So I have the scope ground just hooked to chassis ground, and then one of the scope is hooked to one of the ends of the choke here, and that's safety wise we're okay here. But this is the power transformer, the bigger transformer, and its output's about 21 volts, which is not enough to give you a shock, but you'll feel it. However, the input is the line voltage, 120 volts AC. So, and you see that it's not even isolated, not even, it's all out there. So what I do is I always unplug it. Like the minute I'm done with it, unplug, just make sure that there's no chance of any voltages. The other thing is that this plug is non-polarized, and so you plug it in one way, you plug it in the other way, you could have the hot wire be hooked to this side or that side, and so it is super easy to destroy your scope if your ground is hooked up to the hot wire, for example, of the power here. And so just be super careful, and what I do is I just stay away from that area and keep the receiver plugged in and running only for the minimum amount of time needed to measure my voltages or run my test, and then just unplug it immediately from the wall, from the outlet. That's just a note on safety. Just be careful. So as we start recapping the audio and power supply section, I want to just kind of take a look here at the top of the board. I'm going to start with these three 1000 microfarad capacitors. So you'll desolder these first and then replace them, and that's just to make room on the board because the new one's going to be quite a bit smaller than these. I always get really good capacitors to replace in projects like these. Usually get things that are capacitors that are 105 degrees Celsius temperature rated, at least 10,000 hours. The particular ones I'm going to put in here for the replacement 1,000 microfarads are actually rated for 15,000 hours, so they should last for quite a while. So we'll start with those, and as far as the tools that I'll be using, here I'll show you this desoldering tool. I'll zoom out a little bit. And this tool is really good because it heats up really hot on the tip, so you can actually adjust the temperature, but it's really hot, so it really melts the solder really quickly. And it has a high performance pump here to suck the solder out, and so that leaves a nice clean hole there, so you can just pull the component out without having to potentially damage the PCB or the component or both, right? So I found this technique to be the best with this tool, and you can go online and find these tools, but this one is really good, and I really like it. So we'll be using this one to desolder these capacitors. Just going to show you here. I'm going to go through the whole circuit here on the camera, but I will show you like the first capacitor what I'm doing. So these two solder joints are for one of the 1,000 microfarad capacitors. So first I'm going to use the desoldering tool to remove the solder, and basically what we'll have to do here is just melt the solder a little bit. And just suck it up. So first you melt. And there you go. That's as simple as that. Now, the component has bent pins, so we'll see how easy it comes out. But basically, I'd reach on the other side and try to get the component out. If it doesn't work, then I basically use just a simple screwdriver to bend the pins back. So just turn the board around. This was the capacitor that just unsoldered, and I bent the pins a little bit with just a screwdriver, just to straighten them out because they were just kind of bent over, just to hold it on the board a little bit better. And just as simple as just pulling it out, trying to get that out, and just kind of wiggle a little bit to get that capacitor out of there. And this one is a little tougher to come out, but there it is. So that's as much as we need to be doing there. And it's luckily on the circuit board we have the positive negative marking, so I don't need to remember which side. But just as a good practice, I've taken pictures of this board from every which angle, just in case I mess up or there's no markings on the circuit board. I can always refer back to the pictures to see what capacitor was in there and what polarity, what direction was it in. So that's important. Here's the new capacitor that will go in place. This little orange color capacitor is there's 1,000 microfarads, 25 volts, same as the old one, same ratings. However, it's much better. So it's 105 Celsius rated. I don't know if you can see that, but it's also rated 15,000 hours. So that's going to be definitely a lot better than the ones that were in there. And so I just watched for polarity on the board. There's a plus and minus sign right there, so make sure that the minus lines up correctly. And just put it in there. And the nice thing is with the desoldering gun that I have with the vacuum, the solder is pulled away from the hole, so you can just slide the new capacitor in there without having to worry about solder being left in the hole and plugging it up. So it's as simple as that. So next we'll just solder that on the other side, and there's one capacitor. Let's measure the capacitance of the two capacitors. On one end we have the old capacitor, supposed to be 1,000 microfarads. On the other hand, we have a new capacitor here that I bought, also 1000 microfarads, and just see, you know, how these capacitors sort of compare as far as capacitance. So I have the meter set to 2 millifarads, so that should go up to 2000 microfarads. And so I'll just let's connect this first, and then let's see what the old one is showing us. So it looks like that's 1055 microfarads. This is a plus or minus 20% capacitor, typical. So that's within the tolerance. But it should be a warning flag if the capacitor is reading higher. It's not that these capacitors are overperforming by whatever reason. You know, you should always be careful about, you know, what else is hiding in that capacitor if it's reading higher. And then let's compare that to this fancy brand new capacitor. This is a very high quality capacitor, and you know, I even use these to calibrate the meter. They're very accurate, very high quality. So we're right at 1000 microfarads with that one. And so, you know, that doesn't tell us much. It doesn't. You know, the meter says they both look pretty good. This one's a little higher. As I said, that's a little bit of a warning, but it's not necessarily concerning you. Just using this meter to measure capacitance. And magically, the board is recapped. As you can see, I've put in these orange 1000 microfarad capacitors, as well as I've changed all the other little capacitors here on the board. Now, I haven't tested this. We're going to find out together if this whole thing works. So that's going to be exciting, but at least it's all done. The recapping went pretty well. You know, most of the capacitors were easy to get to, easy to get access to. You know, as I showed you before, I use a desoldering tool to suck the solder away, and then the capacitor just falls out on the other side. This is also a new capacitor, this blue one here. And, you know, that one just put back to where it was. The issue was this little corner up here. There's about 5 or 6 capacitors all clustered there. Plus, it's kind of tight in the corner, and there's lots of wires connected. So, what I did is I've taken a whole bunch of pictures just of that little area, desoldered the wires, and then, you know, put all the capacitors in there. So that was a little more difficult. And, you know, I opted to keep the board in instead of taking the board out and then recapping it. And the reason being is because you just see all these wires soldered all the way across the edges of the board. And that I thought would be more difficult, and there's a chance I could break a connection or a wire or something else. So I thought it was safer to leave the board in and then recap it like that. Okay, here's the moment of truth of testing the receiver if it works after recapping. And turn the lights off, so hopefully we can see the incandescent light in the receiver if it works. Alright, let's see. There's definitely seems to be something going on. And I hear something, which is good. Let's start tuning a little bit.
With 15 seconds to go. As the head of the lightning zone lifted out by Hedman.
Well,
and that's going to
looks
do
like
it.
we're
10 seconds to go.
doing good here.
Down the boards. It's broken up by Kucherov. It's cleared out of the zone.
You can hear the narrow, normal, and low tones here.
Won it 3-1.
How it changes
and they
the
lead
audio.
the series. But that won't stop my loving you. I just can't let you.
Okay, well the audio sounds good, so I think we're pretty good with the new capacitors. Next, let's check how the tuning works. You know, my biggest concern here with these receivers is the main tuning knob to see how well it tracks. And luckily for this receiver, we don't have to use an external signal generator to test this. The manual has a procedure where we can test the tracking of the main tuning knob. So basically making sure that we're at 0 to 1 megahertz on this knob for all the bands, which is an internal test. So a test calls to put the mode to LSB, so that's the top one here, so LSB mode, and then we set the megahertz to the little arrow. There's a little arrow there. Maybe we'll see it once I turn the receiver on a little better. And then we want to look for a 0 beat at both ends of the dial. So, at the 0 mark, we want to hear a 0 beat. And at the 1000 mark, we also want to hear a 0 beat. And now, of course, there's this mechanical dial set here that we can always change. And really what that does is just shifts the band around. It doesn't change the edges. This tuning is for changing the tracking or the edges of the band. So we'll test that first. There is a radio station here that it is broadcasting at 1000 kilohertz, and so we can actually adjust the mechanical band to that radio station. So we'll do that next. But first, let's do the 0 beat tuning. So I have it set at the 0 mark here in the megahertz, and then LSB there. Well, I would say that's right on. I don't know if I can see it on camera, but that's right on 0, the 0 beat. Now let's go all the way to the other end, the 1000 mark. And that is also right on. So I think we're looking actually good on this receiver as far as the tracking is concerned. So now we're going to check how accurate is the frequency dial. I already have the receiver on and set to the 1 megahertz band here for AM. And so at 0 here, we should be at 1 megahertz. And I have it set to AM, and so there is a station right at 1 megahertz or 1000 kilohertz, and we'll see where that lands. It's right about there. Now, we could be just to time it off, and all you do is just adjust this mechanical knob here that moves the needle in the front, and that's it, and we're done. So we know that the receiver is accurate and the edges of the band are tracking well. So for now, I think this is the extent of the tuning I'll go through. There's obviously many ways you can tune this receiver, like going through a full tuning procedure where the internal filters and IF filters all need to be tuned. But like I can see that the receiver is working well, so there's no need to mess with those unless the receiver sensitivity is not good. So well, obviously I'll do some more tests. We'll actually try this out at night and try to receive some DX stations and see how that works. And if the sensitivity is low, then I might go through the full tuning procedure. But with the full tuning procedure, you're likely going to actually mess up the tuning, because the factory procedure has been carefully done, right? So it's a pretty tricky process to actually tune some of these receivers, and so more likely than not, if you actually want to tune it, you'll actually end up with worse tuning than what was done at the factory. Now it's time for reassembly, and the first thing that I'm going to put back on is this front rim here, and this just goes on like so, just like that, pretty simple, and then there's a couple of screws on here on the front and the side, and so just need to get the screws in like so. So that's the front, and next comes the chassis. So chassis just basically slides on from the back, and it kind of goes in like that. It's a little awkward. See receiver kind of goes in there. Basically goes all the way to the front and just slides in, you know, from the back here. So next, put the screws in there, and then it should be all complete. I wanted to show you one tricky part when putting this together. In the back here, there's this little 90-degree angle lip that goes in there, and the way that goes in is that there's a screw holding it from the top, which you can always take out as well, and a screw holding it on the back here. So the top screw, these screws are kind of colored to be the same frog green as the case, but the other screw is just a standard non-colored, non-painted screw. And so that kind of goes in there, and the top screw is fastened down like so. That just keeps this front panel kind of so it doesn't bend in, or it's kind of nicely held over here. One other thing that I talked about a little earlier is the speaker grill here is a little couple of areas where the paint is sort of scratched off of it. So I'm using this paint pen to basically, I'm just going to touch it up, and then I'm going to just wipe it with a alcoholic wipe, just so I blend the paint in. So so basically just a little touch up. I'm not going to paint the whole thing, but just going to touch that up, and then so I don't see those dots there, I'm going to blend it in with just the alcohol wipe, and then that should look really nice. Okay, so after a couple of wipes here a little bit, just blend that paint. Looks good as new. So that's as simple as that for fixing those small little scratches there. Let's actually try to receive some stations with the receiver. Before we do so, I'm going to set it up to receive on an AM band, on a broadcast band. So the thing to look at here is that where to connect the antenna in the back. Do not connect it to this one, nor to this one. It's going to be this jack here, this plug here, which says broadcast band on it, and I just have a wire antenna connected to it, so nothing fancy, just a little bit of a wire. It's maybe 20 feet, I guess, and so we'll just see how well it receives during the daytime here. Okay, so the way we tune the AM band is in two stages. So the band selector switch has to be in the A position, which is 0.5 to 1.6 megahertz. But since this radio only receives in 1 megahertz increments, so the fine-tuning knob goes from even numbers of megahertz, we need to tune the AM band in two stages. So one stage is half a megahertz to 1 megahertz, and the other stage is 1 megahertz to 1.6, 1.7 megahertz. And so to start with the lower end of the AM band, so I have the tuning knob at A position here. I have the pre-selector somewhere in the 0.6, 0.5 megahertz range. That one is only when you find a station you can fine-tune that a bit. But most importantly, the megahertz selector has to be on the 0 megahertz block here. So meaning that we're going to go from 0 kilohertz to 1 megahertz in this tuning knob. So all the way down here, technically it's 0 kilohertz. Of course, we're not going to receive anything there. But as we start going up the band, we're going to start reaching the AM band here, right here, at about 500 kilohertz. All right, well, let me tune the volume up a bit. And let's see what we can hear.
Care is going to be paid for, and it's going to be managed, and that's why we have insurance. There's no maybes on that. We're not buying it because maybe the stock market will be okay, and maybe they'll pay me back. Which guarantees. We burned another weekend.
And one more note though, this lock light is supposed to indicate if you're locked on that 1 megahertz range, and look, it seems to be working pretty well. All I can see that it tunes just fine, without that lock light on as well. So it's really just a analog indicator.
longtermcare.com. We'll be
those guys are probably going to run because I really don't think they get assigned. I think they have the green light. So as a hitter, you're not sure when they're going to go. It's not the third base coach telling you, I want you to go now. It is when they feel that they have an idea of maybe when he's going to throw a breaking ball, get a bigger lead, and get a good jump, and then they take off. So I think as a hitter, you're going to get some mistakes in those situations, and you should be in the middle line of open.
football with our football co-host Brett Roberts.
Man, not maybe once a month be able to get better control and better outcomes, but it's not going to replace some of the visits.
Leonard bullies his way down the lane, passes to Zubats right at the pin for the layup.
I'll tell you what, talking about making a hey, really. The success stories and to schedule your free consultation, go to impactwashington.org. All around the sound, the sponsor spotlight. Brought to you by...
Okay, so that's the lower end of the AM band. So to tune the upper end of the AM band, so you get the tuning knob all the way down to basically the 1 megahertz range. So this will now be 1 megahertz because I'm going to move the megahertz to the 1 megahertz indicator here. And there you go. And so I'm going to make sure the preselector is somewhere on there, just set correctly. And
pennies on the dollar.
so now we're listening to the same station we listened before at 1 megahertz, but now the 1 megahertz mark is actually at 0 here. So going up on the dial will go above 1 megahertz.
Welcome back to Mystic Radio for past lives, people, and pets from mystical Mount Shasta and in the shadow of White Horse Mountain in Darrington, Washington.
I think that about does it for the AM band. Now there is a little bit of hum, and that's not coming from capacitors or anything else. It's just coming from this simple wire antenna picking up all kinds of AC here where I'm at. So having a better antenna with the ground and all that kind of stuff will get rid of that hum. But I don't have this set up right now. But otherwise, it's receiving really well in probably the worst AM conditions. It's about noon here, so it's not the best conditions for AM, but it's actually doing pretty well. So later in the afternoon, we'll try DXing in the shortwave bands and just see how that works, and see if we can pick up some stations that are far away or low power, and we'll see what we get. Well, how much we can get with this antenna that I have here. So really, it won't be that spectacular, but hopefully we'll be able to receive a couple of distant stations. Here's a test of daytime, as in worst conditions, shortwave reception. A good test is always to listen to the National Institute of Science's time broadcast, which is coming from Colorado, and it is on 2.5 megahertz, 5 megahertz, 10 megahertz, and I believe also on 15 megahertz. And really, it's just a time signal that there's a AM modulated voice and a tick-tock on it, and the nice thing that the frequency of those transmissions is very precise. So the 10 megahertz can be used to tune the radio receiver and kind of make sure that the dial is tuned correctly. So here I have I have the volume turned down, but here I have the time signal coming from Colorado here. And hopefully we'll be able to see it. So the way I have it, be able to hear it. So the way I have it tuned is that I have the band switch on C here, which is 4 megahertz to 11 megahertz. I have the megahertz selector on 10 megahertz, and I have the pre-select at 10 megahertz as well, or around there. So let's just see. It's really faint, but you can hear it a little bit. You can hear the tick-tock in the background a little bit through the noise. Anyway, not super great reception, but actually pretty good for a transmitter that's about 1,000 miles away from here, and probably in the worst conditions at about noon today. The sun's out, and so that's pretty good. We'll try this in better conditions and see how well it does. Well, it's about 8 o'clock at night here, and the conditions should be a little more favorable to listening to shortwave. I've attuned the radio at 10 megahertz to the clock signal in Colorado, and it's coming in quite a bit nicer than earlier, even though the antenna is not the best.
The estimated planetary change except 0 UTC on August 31st was 3. No space weather storms were observed for the past 24 hours. No space weather storms.
Found a couple of faint transmissions on the 7 to 8 megahertz band here, so basically in the 40 meter band, but I guess we're above that, so the dial now reads close to 8 megahertz, so this will be 8 megahertz right here. So we'll browse a little bit backwards so you can see what we can hear. Probably some computer generated signal. And we just entered the amateur band here at 40 meters at 7.3 megahertz. So carefully go. In fact, I'll switch to USB here. Here's a speech transmission of some sort. Possibly. Hard to tell. There's a CW transmission, that's coming in pretty clearly. I have it on the CW setting here. You can always listen to LSB as well. It doesn't really matter, but USB is usually most common. Now, I'm not that good of reading CW just like by hearing it, but this is actually pretty slow, so with a little bit of practice, this is pretty easy to, should be pretty easy to read. There's quite a few more here. Just have to go really slow. There's a faint one. So yeah, just a little bit of browsing in shortwave bands. You know, we can obviously spend a lot of time going through all the frequencies all the way from AM all the way up to 30 megahertz, and so lots of fun and try to find stations at this time. So yeah, let's just show you a little bit how the receiver works. Thanks for watching this two-part series of the Yeesu FRG-7 restoration. Hope you enjoyed the video, and let me know in the comments below. I'll be happy to answer any questions if I can, and stay tuned for more exciting and neat projects. I have a Macintosh that I'll be restoring. Also, there's other receivers and electronic projects that we'll be either restoring or building. We'll probably get to some coding as well, especially on the Mac, or we'll actually look at the Spectrum ZX computer as well. So thanks for watching, and see you soon.